Welcome to clickmyproject.com. Now let me discuss about segmentation and tracing of single neurons from 3D confocal microscope images. Here we propose the method to segmenting and tracing the single neurons. We developed tree-to-tree, a robust automatic neuron segmentation and morphology generation algorithm. Tree-to-tree uses a local medial tree generation trajectory in combination with a global tree linking to build a maximum likelihood global tree. The single image neuron will be the input of the process. In pre-processing, we remove the noise from the image and then we enhance the neuron image. Then we find the gradient of the image. After that, we find the binary image is generated for the neuron image. The binary image will be segmented by the Hessian based method. This method is determined whether the pixel is belonging to the neuron structure. If it is belonging to the neuron, the pixel will be marked as a 1 and another pixel are marked as 0. After segmentation, we are tracing the neuron with the original image. Here we trace the neuron by the use of alpha-beta graph pruning algorithm. Finally, we map the segmented neuron to the original image. Now let's see the flow of our project. Here we have to provide a neuron image as an input. The provided neuron image is passed to the pre-processing stage. Here we are applying a Gaussian filter to our input image. Gaussian filter is often used to remove the noise from the image. We use to infilter function to our input image. Gaussian filter is windowed filter to linear gloss. The noise-free image is passed to the enhancement. In enhancement, morphology is a technique of image processing based on shape. Here we are enhanced the region of that image by the use of top hat and bottom hat function. Top hat filtering is used to correct on uneven illumination when the background is dark. The top hat operation contains the peaks of that object that it fit to the structuring element. The enhancement image is passed to the binarization. In binarization, here we convert the neuron image as the binary image. Binary image is a black and white image. It contains only the zeros and ones value. For transforming the binary image, here we are using the Hessian based scheme. It determines whether the pixel belongs to the neuron structure. If it is belong to the neuron, the pixel will marked as the 1 and the other pixel are marked as 0. In its simple form, Hessian based vessel enhancement might be viewed as a filter that enhanced. The binary image is passed to the neuron tracing. Here we are tracing the neuron in the input image. For tracing the neuron, alpha-beta graph pruning algorithm will be used. It is a search algorithm that seeks to decrease the number of nodes that are evaluated by the mini-max algorithm in its search tree. It stops completely evaluating a move when at least one possibility has been found that proves that the movement is to be worse than previously examined moved. After neuron tracing, it will pass to the neuron segmentation. After finding the neuron, the segmented neuron will be mapped to the original image. Finally, the mapped image will be displayed, and then finally we get the segmented result of neuron. Now let's see the execution part. Here I am having main.m file. This is the main file. Select this file, right click, run the file. The guide window will be open. This is our guide design. Here we have to provide our input image. In dataset, totally I am having 5 images input. Now I am providing one image. The provided input image is displayed in the first axis. The provided image is passed to the pre-processing stage. In pre-processing, here we are removing the noise to the original image. Here we are removing the Gaussian noise. The noise-free image is displayed. This is the noise-free image that is displayed in the second axis. The noise free image is passed to the enhancement. In enhancement, here we are enhancing the intensity level of input image by the use of morphological operations such as top hat and bottom hat function. The enhanced image is displayed in the third axis. The provided enhanced image is passed to the image gradient. Image gradient is nothing but the finding the edge of image. Now let's see the result of image gradient. This is the gradient of image. The provided gradient image is passed to the binary session. In binary session, here we are converting the image as a black and white image. For this, here we are segmenting the neuron by the use of Hessian based method. If the pixel is belong to the neuron, it is marked as 1. If it is not belong to the neuron, it is marked as 0. Now let's see the result of binary session. This is the binary image that is displayed on the fourth axis. In localization, here we are tracing the neuron to the original image. For tracing the neuron, here we are using the alpha beta graph pruning algorithm. Here the neuron is traced here by the use of contour. Iteration is going on. This is the traced result of input image. This is the segmented result of original image. This is the 3D rotation of the provided neuron image. Here we can see the 3D rotation to the provided input image. Now I am showing the result of segmentation and tracing of single neurons by the use of alpha beta graph pruning algorithm. Thank you.